All right. So, IP routing. This is a relatively short chapter. My intent is to go through chapter 9 and then to, for those of you who need it, to work on Lab 8. How many of you have Lab 8 pretty much figured out? Okay. How many need a little help with Lab 8? How many have not even tried Lab 8? Oh, okay.
I feel like everyone's focused on your other lab. You know what I mean? Lab 4, the way you try to do the active directory stuff.
Lab 7?
No, 244.
Okay, well we're in 235 right now, Steve, so I'm not talking about 244.
No, but like Lab 7 is like a bit fun. Like, it's confusing though, but...
Oh, Lab 7? Yeah, that was fun.
Because I was like, oh, where's this go? Like, I was unable to find all of them. I was like, ugh.
All right, so in either case, in this chapter, we'll talk a little bit about how does routing work, what are such things as, default routes, static routes, dynamic routes. Talk about how we measure routes and we figure out what the best path for a route is, and so on. So let's just get into it. All right. So an important list of minimum factors a router must know to be able to effectively route packets is 1, what is the destination of the packet? And so what it's looking at is routing runs at what layer of the OSI model? What layer of the OSI model? 3. Okay? And at layer 3, what is the protocol data unit? Protocol data unit. Yeah, it's an IP packet.
Oh, and a TCP as well.
No, that's layer 4. That's layer 4. So at layer 3, we're interested in packets, IP packets. And in that is going to be a source IP and a destination IP. The other thing that we want to know is who are our neighbor routers. Okay? That's the very beginning of figuring out the network. Routers, if they are figuring out routes dynamically, in other words, they are figuring it out on their own and not being told by us as the administrators, they have to discover the network. Just like you discovered the network a couple of weeks ago with Lab 7. You went through trying to figure your way out. Well, what happens with routing protocols is they try to figure out the layout of the network in order to figure out what is the best path. Okay? Possible routes to all remote networks. So what they do is they collect all of this information. Good routes, bad routes, and then they sit down and they say, what is the best route to each network? Okay? Now in Lab 7, no, in Lab 8, how many networks were there? Lab 8. How many networks were there in Lab 8? Okay, there were 4. Okay? Where am I picking that up? Just make sure I'm getting this. Yeah, I'm recording everywhere. Okay. So we're in good shape. All right. So in either case, we're going to determine the best route to each remote network. So the number of networks we had in Lab 8 were 4. There were 4 networks. Each network has its own network ID. Next, how to maintain and verify the routing information. So one of the things that occurs is that routing protocols will literally talk to one another. They will send other routers and they'll say, oh, by the way, I'm connected to this router. Okay? And based on that information, other routers are then able to determine what is the layout of the network and what is the best path. The router learns about the remote networks from neighboring routers or from an administrator. The way we teach it as administrators is we create static routes. Okay? And it's only on the exception that we are going to define static routes. Okay? You don't want to be in a situation where you are in a network, in a real world environment, and you are specifying static routes. Okay? Every once in a while, you'll have a static route and essentially what you're doing is you're saying, I don't care what the routing protocols say. I want you to, if you're going to this network, I want you to take this path. Okay? And that's where you use static routes. That's where, as the administrator, you're defining a static route. Okay, so the router then builds this routing table, and it's based on what the administrator has said in terms of static routes, also about what routing protocols are saying. And there are multiple routing protocols. You've only seen one, and that's RIP. But there's also OSPF, okay? There's EIGRP. And what occurs is the router is listening to all of these protocols, taking into account all of the information, and then making a determination based on all of the information that is collected. Some routing protocols, it feels greater reliability to that protocol. Okay? For instance, RIP has a very low rating. Okay? Something like EIGRP or OSPF has a higher rating. So if the OSPF routing protocol comes in and says, this is the best route to network X, okay? And RIP says that I think this is the best path to network X, it's going to listen to OSPF because there's a value in there that says, I have more confidence in OSPF than I do in RIP, okay? And we'll be going through that table in just a minute. If the network is directly connected, then the router always knows how to get to it. Okay? So the first thing that it looks for, the first thing that the router asks for is, who is directly connected to me? What network IDs are directly connected to me? Because I don't care what any of the routing protocols say. Okay, if I have a network that is directly connected to me, I know I'm always going to go there. Okay? All right. So here's an example, okay, of a very basic network. Can anyone tell me how many networks do you see here?
4.
There are 4 networks. There are 4 networks. Okay? We've got this network, this one, and this one here. And you'll notice that they have varying or different subnet masks. The very first one has a /8 or a 255.0.0.0. The second network has a 255.255.0.0. No, 255.255.255.0. And then the one down below is just 255.255.0.0. Good. Okay? And we really don't know about this network here. We don't know what IP address it's or network ID it's been assigned and so on. Okay? No, because even a serial connection, as we've seen, a serial connection is a network. And how many interfaces are on this network?
It's supposed to be 2.
Only 2. So I only need 2 IP addresses, right?
Yeah, but for the subnet mask, would it just be like 192.0.0.0?
No, what would the subnet mask for something like that be? Whenever you have a serial connection, what would you make for this? It's always going to be something like 255, 255, 255, 252. Okay? And what I want you to think about is if you've got the value 252 and you write that out in binary, okay?
That probably the first like the 6 like ones and 2 zeros basically, because the 2 and the 1 on zeros. You know what I mean?
Yeah, hold on. So you just take the 252, okay? The last octet. What is that in binary?
6 ones, 2 zeros.
Very good. Okay? And what is the value of that one, the rightmost one? 4. So that means what's going to happen is you've got a block size of 4. Very small. And because we know that we cannot use the network ID and we cannot use the broadcast ID, how many usable IP addresses are there? 2. Okay? 2. All right. All right. So one of the basic commands that you'll get to know, and you probably have already used, is show IP route. Now, what mode do you use this command? User, privileged, or global configuration? Privileged mode. Show is always privileged mode. Okay? And what would you need to do to run that command inside of global configuration? Do show. Okay. So what is this saying? Well, it's telling us a couple of things. To begin with, it comes out and it says that the 10.000 is subnetted into 6 subnets. Okay? And so what we have is that we've got a /8, we have a /32, okay? And where is the, which is locally connected, okay? Then we have a /16, a /24. And then we've got serial 000/0 is directly connected, okay? And we'll talk about that one separately. But you'll notice the C's. Each line that says a C. That's telling you that it is directly connected. Okay? And we saw that in the diagram back here. These are all directly connected to Lab08 router right there in the center. Okay? And then we have the serial connection down below. Okay, so let's take a closer look at the actual routing process. How does it work? So the process is simple, however, there are many steps. And regardless of the size of the network, you still have to go through those same steps. So in either case, in this diagram, how many networks do I have? I have 2 networks. Okay? I have, let's call it network A and network B. What is the well, I can't tell. I can't tell what the subnet mask is because I don't have that information. All right. So I'll just leave it. So in either case, what happens is if you were to look at the routing table on this, you would see that the network, I'm just going to say 172.16.10.0, is connected, is directly connected, as well as 172.16.20.0. Okay? So these two networks are directly connected to my router. All right? One is on E0 and the other is on E1. Now you haven't seen E0 or E1. What is that? That's Ethernet. Not fast Ethernet, 100 megabit, or I'm sorry, 10 megabit Ethernet. Okay? You can't even get those interfaces anymore, so let's look at something a little more complex. So this shows a LAN connected to router A, okay? That's then connected via a WAN link over to router B through port serial 00, and then to an HTTP server. And the TCP destination port is 80 because we're going to a web server using HTTP. Okay? So let's walk through this. First, the destination address of a frame for host A would be the MAC address of the router's F00. So we start out by wanting to send a packet to router 0, okay, an IP packet to router 0. But probably what's going to happen is it's going to go looking in the ARP table for the address for F00. What is the IP address for F00? And it's then trying to look for the MAC address. But it's not going to happen or find it, and it's going to send out an ARP. Okay? So the destination address of the packet would be an IP address of the HTTP server's network. Okay? So host A is sending over to our HTTP server. But first it needs to get to the router. And if you look at the IP packet, the destination port on the IP packet shows 80. And that's fine. Okay? But the packet is first going to be forwarded to router A. Router A is then going to look at the destination IP address, which is our HTTP server, and it's then going to look at its routing table. And the routing table is going to tell it to send this packet through what interface? Router A is looking at this inbound packet and it's trying to figure out what interface do I need to send this packet out on? Through the serial 00. So then it's received by router B on port S00. Or router B then looks at that same packet and it says, okay, well, what's the destination IP address? Oh, okay. The destination is this HTTP server. Does the router care that it's port 80? You know, we said that we are sending it with port 80. Is the router concerned? No, the router does not care about ports. Because ports have to do with have to do with layer number 4, the TCP or UDP or transport layer. Okay? All router B is trying to do is identify the network that we are going to send this thing to. And that's this network right here. So the router goes looking for the IP address. It finds that the best path to send it is F00. Okay? All right. Again, this shows a network. How many networks here? Only 2. We're essentially counting the number of connections to the router. Okay? So the destination address of the frame from host A would be the MAC address of the router's F00 interface, and the destination address of the packet is the IP address of the HTTPS server. Okay? Next, the destination port in the segment header. Remember, the segment is what layer? Okay? Frames are layer 2. Okay? Layer 1 is the physical layer is bits. Okay? The data link layer is frames. The routing layer or network layer is packets. Okay? Layer number 4, the transport layer, is segments. Okay? Or sometimes we call them datagrams. Okay? So, the fact that we're going to port 443, what does that tell you? Yeah, HTTPS, not just HTTP. Okay? Port 80 HTTP is a web port, okay? A web server port, but it's unsecure. This is a secure port, okay? All right. So basic IP routing using the MAC and IP addresses. So in order to communicate with the sales server over here, okay, host number 4 sends out an ARP request, and how will the devices exhibit the topology and respond to this request? So if 4 wants to communicate with the sales server, it's first going to put together a request, and it's not going to have the MAC address to router B. So it sends out a request, an ARP request, and says, hey, router B, all right, what is your MAC address? But in order to do that, it needs to, when it sends the ARP request out, what information is it giving? What information is it providing? What do you know about the router? What do you know if you're sending information? I'll tell you what, let me back up just a little bit, because he's really not doing a very good job here. Let me pray and hope that one of these markers works. So we're going from nope.
What the heck? What's that?
Okay, this works. So, workstation 4 wants to communicate with the sales server. So the first step is, in order for 4 to even get started, it must know, well, where is it going, okay? So what it wants to do, we know that we've got 3 networks here, right? We're going to call this network A, network B, and this is network C, okay? Every network has its own network ID, right? Okay, so workstation 4, I'm just going to make this up, it's not here. has an address of 192.168.10.10 and /24. Okay.
Yeah.
So it has an address of 192.168.10.10, and it has a default gateway. You remember where you set the default gateway? So the default gateway is what? What is that address? Okay. That better be the address of Lab B router, okay? Now, based on a /24, what is the default, or what is the network ID for this network for workstation 4? What is the network ID?
10.0.
10.0. Okay? And I know that the sales server, that its address is 10.1.1.100. Okay? So I look at my network address on workstation 4, which is 192.168.10.0, and what's the network ID for the sales server? It's going to be 10.1.1.0, okay? And these guys aren't able to hear this. Or they're not able to see what I'm writing on the board. Let's do this. Yeah, that's what I'm going to do. So workstation 4, that's 192.168.10.10 with a /24. The 192.168.10.1 is the default gateway, which happens to be Lab B router. All right, the network ID and the sales server is 10.1.1. Now, can we safely say that workstation 4 and the sales server are not in the same network? Would it be safe to say that? Okay. So at that point, workstation 4 knows that it's communicating with a device not on its default network. And we saw that, right? Sales server's over here, and workstation 4 is over here. Okay? Okay, so because of that, because of that, it knows that it needs to send its packet. In order to get to the sales server, it has to send the packet to where first? Before that, it has to send it to the router. Has to send it to its default router. Okay. So it knows what is the address to the default router. Right. So it knows the IP address, but it doesn't know the MAC address for the router. How does it figure that out? Well, it has the IP address, okay? But it has to figure out the MAC address to the router's interface F00. What's the MAC address to that? What protocol do we use for figuring out MAC addresses? We use ARP, Address Resolution Protocol, okay? So what ARP does is it says, okay, put the IP packet on hold. Just hold it here for temporarily. And create a request, an ARP request, and send that out. And when it does an ARP request, does it send it to a specific station? It's a broadcast. It is a broadcast. And it sends it to all of the systems that are on network A. So workstation 3 is going to see this, as well as Lab B router is going to see this. So what's going to happen in that ARP request, it's going to say, I am looking for the device that has the address of 192.168.10.1, namely router B. And router B is going to respond. It's going to say, hey, that's my IP address. So it then responds to that ARP request with its MAC address. Now workstation number 4 has the MAC address, has the IP address, and what it does is it sends out another frame, okay? And in that frame is the source address of workstation 4. And what's the destination address of that frame?
It has the MAC address to the router, so that's going to be the destination MAC address.
The destination MAC address is going to be that of the router, okay? But what is the destination IP address ultimately of my packet? Is it of the router?
No, it's going to be of the sales server.
Of the sales server, okay? So it gets up to the router. At this point, the router receives this IP packet, and it is now going to look at the routing table, and it's going to figure out, in order to get to network C, what is the best path to go on. And that is through serial 00. And it's then going to send that packet through serial 00 over to Lab A router, okay? Lab A router is going to look at this packet again, and it's going to say, okay, where is this packet going? What is its destination IP address? Okay? And that router is then going to say, oh, okay, in order to get to that, I want to go, out through port F00, okay? And then ultimately on to server or to the sales server, okay? Is everybody following this? Okay, honestly, I'm surprised. The problem is that, believe it or not, this is a simple process, but there are many working parts to it. If you look at a little piece of all these, yeah, it's very simple. But trying to get all of this to work together and explain it is not easy, okay? So I'm glad that you're getting it so far. All right, so setting up IP configuration. There are three ways to set up IP routes: static, default, and dynamic. Now, static is when you, the administrator, define a route. And what you're doing is you're telling the router, if you want to go to this network, this is the port that you must go through. Okay? Dynamic routing is what routing protocols do. So if you're running RIP or OSPF or EIGRP, the routing protocol figures this out. Okay? And it dynamically changes the routes based on what's needed. Okay? What is default routing? No, it's not supplied by the device. It's something that the administrator generally has to put in. Okay? No. No, it's not. Well, typically when you say default, what does default mean? Generally to me, when somebody says default, it says unless it's specified otherwise, then this is what you do. And that's what default routing is. It's not a process, it's a definition. And what we're saying is, if you're not sure about where to send a packet, or if I give you a network ID and you're not sure where to send it, here is the default route that I want you to send it to. Okay?
So I guess typically we just send, we set the default routing just to the router itself.
Yes, we will actually define a default route statically. Statically. Okay? And remember that it's only going to use the default route if the routing protocols don't give it a suggestion or our static routes don't tell us. Okay? So this is like the backup plan. Okay? Unless it's specified elsewhere, then this is what we will do by default. Okay? All right. Okay, so this is how we set up a static route. This is the command that we use, and this is a global configuration command. So the command IP route, then destination network, and that's a network ID. Okay? Which? Oh, sure. I can do that. All right. The next piece of information is the mask. Okay? So the mask is going to be in a dotted decimal format. Not a CIDR format, but dotted decimal. Right? No. Dotted decimal is like 255, 255, 2550 rather than a /24. Okay? Now, next, you see the square brackets. So you've got next hop address or the exiting interface. I always like to use the exiting interface, okay? And we'll explain what that is. But you'll notice in this parameter, we have a choice of one or the other. You choose whichever one you want to use. So either the next hop address or the exit interface. Administrative distance. Remember how I said that the routing protocols, some protocols, the router feels more confident with some protocols rather than others. So EIGRP, it has a lot of confidence for, okay? But RIP, not so much. Well, what happens is RIP gets assigned a higher value, meaning lower confidence, kind of backwards. And directly connected connections get a value of 0, which means very high confidence, very high. Okay? Yep. So, in either case, we'll get into administrative distances here in just a moment. And then finally, we've got this thing called permanent, as to whether or not we are going to keep that route permanently there, regardless. Okay? The times that I've had to use permanent are few and far between. So here are a couple of examples. Okay? An IP route 172.16.3.0. And notice the dotted decimal 255, 255, 2550. So the 3.0, what is that? Is that a host address or is that a network ID address? Network ID. Okay? So, and what is this parameter right here? 192.168.2.4. Let's go back. Let's go back. That's going to be the next hop address. Okay? The next hop address. All right. So that's fine. Let's take a look at the second one here. Right here. IP route 172.16.3.0 with a 255.255.255.0. 192.168.2.4. Okay? 150. What's the 150? That's the administrative distance, Dave. Yep, very good. Now, if 0 is high confidence, what's 150? No, low confidence. Low confidence. Okay? So, a value of 150 is any of the other routing protocols will override this. Okay? If the value is 255, it says do not send it down this path. Okay? All right, how about the next one? We've got IP route 172.16.3.0 with a 255.255.255.0 S000.
So that would just be, so instead of putting the address in for the next hop, it's just going to put
It specifies the exiting interface. So the exiting interface in this case is serial 000. Okay. The rest of these guys aren't going to be able to see this, but I figures all the erasers are down here. so I'll put this in the recording. All right, now I'm on router 1 and I want to create a static IP definition to get me onto the network for 10.10.10.0. Okay? So I'm on router 1. Let's go over the command. Okay? So, what is my destination network ID?
So just
10.10.10.0. All the way over there on the right-hand side. Okay? And what is the subnet mask for that network? Very good. And now I have a choice. Oh, I forgot to specify the ports on the serial. Both of them are serial 0, or let's do it this way. So we don't use you. Okay. Now, I have two options at this point. I can either specify the exiting interface or the next hop address. So if I specify the next hop address, what is that? Nope. Where are you? You're at router 1, right? So the next hop is to the next router. So from router 1 to router 2. What IP address must I give it?
Oh, I see.
.2, yes. Yes. Okay? Am I going to have a high confidence or low confidence? High confidence? Whenever you have a static definition, by default, its administrative distance is 1. And what that's saying is, if the administrator tells you that this is the route, this is the route. Okay? So I'm just going to put that in. Okay, that 1 is the administrative distance. Now the other way I can go the other option that I have is what is, rather than the next hop address, what is my exiting interface? Is it 0, 1 or 0, 0? What interface on router 1 am I exiting on? 0, 0. Yes. Right there. Okay. Do you understand the difference between next hop address and exiting? You know, they're like two different things, okay? I always like exiting interface because I typically know that faster than I know the IP address on the other side, okay? All right, so that is a static route, okay? And anytime you do a static route, okay, you're going to see an S for static, okay? Whenever you see the S asterisk, that's a default route. And this is where we actually define default routes. And notice what it says. It says IP route. So it starts out just like a static route command. But it's saying 0000, okay, for the IP address, for the network ID. And the subnet mask is 00000, okay? What we're saying is, I have no idea, okay? And we're going to send it to 172.16.10.5. So what is that? What is that address? 172.16.10.5. What do we call that? That is the what? Next hop. Good. That's the next hop address, not the exiting interface, but the next hop address. Is there an administrative distance? No, it's not specified. Okay? All right, so what this is saying is if you don't find, if you're looking for, let's say, network 6532.24.0. If you're looking for that network and I don't specify it anywhere else and the routing protocols do not have it, then you are going to take this path. You're going to go to 17.16.10.5. This is the default route. This is the way out of your network. Okay? Nope. So we talked about the administrative distances. So directly connected is a 0. High confidence. Okay? Static route, which I showed you how to do. That's high confidence. It has a value of 1. EIGRP, that is a Cisco proprietary routing protocol. And it has a better than most of the others distance. Okay? Then OSPF. Very popular, non-proprietary, meaning it runs on both Cisco as well as other vendors, other network vendors. And we've been using RIP up to this point in time, right? And you'll notice that RIP has a value of 120. Okay? So as we go further down the list here, our confidence in these things is dropping. And then finally, we've got external EIGRP, and it has one of the lowest at 170. Okay? Because typically we don't use external EIGRP. Okay? We'll use something else, like a border gateway protocol, BGP. And then finally, the highest value, lowest confidence, is 255. Okay? All right. When we talk about routing protocols, there are two types of protocols. The first, and probably the simplest, is what we call a distance vector protocol. RIP is a distance vector protocol. Okay? And RIP counts hops. The way it figures out the best path is every time it goes to a router, that's a hop. And the path with the fewest hops is the best route. That's how it figures out its best routes. Others, such as OSPF and EIGRP, they use other values, okay, for figuring out the best path. So RIP is really very, very simple, okay? It's very basic. Also, RIP periodically sends out its entire routing table to directly connected neighbors, okay? So that's because it is a distance vector routing protocol. Let's take a look at link state. An example of link state would be, it's also called shortest path first. Okay, the most common is OSPF. Okay, which is open shortest path first. And that is a very popular protocol because it is non-proprietary. It can be used on both Cisco and non-Cisco devices. And it gets a relatively good rating. Okay? OSPF is a lot more sophisticated. It keeps track of neighbors. It keeps track of all of the different networks out there. And it uses a number of different variables for tracking what is the best path. So there are a number of different metrics that it uses for determining best path. Okay? OSPF, being a link state protocol, sends updates containing the state of its own links, not its entire routing table. Only the links that it is connected to does it send that out to the network. Okay? Where, notice with distance vector does what? It sends out its entire table. That table could be rather large. Okay? But link state protocols such as OSPF only send out those networks that are connected to it. Okay? Then you have a hybrid such as EIGRP. And this has both the characteristics of a distance vector and a link state. Okay? And they do this to basically because it's quicker. It's quicker to converge, and it provides a more in-depth view of what the network is and what is ultimately the best path. Okay? So that's EIGRP. Questions? All right. How many of you are going to stick around for our discussion of Lab 8? Really?
Is that
Okay.
going to get recorded? Is the discussion on Lab 8 going to get recorded?
As best I can. As you saw, sometimes I can't record everything. All right. Any questions? All right. For those of you who have already turned in Lab 8 or feel pretty confident that you know what you're doing, you are dismissed. I will not see you next week, so enjoy Thanksgiving. Also, our final gang is on the 5th of December, 2 Thursdays from now. Okay?
After the final's done, I was going to have any more classes or no?
Are we going to have any more classes? Really?
No.
I mean, don't dare me, because I will. I will have classes.
Oh, I maybe like to see like how he did in the class 90, like if there's like.
I'll tell you what, Steve. This is what we're going to do, which is what I typically do at the end of the semester. We're going to go out for pizza and beer.
I'm
All right?
too young for beer.
Now,
I'm 20. I turned 24.
okay, listen. So server 244, I'm going to have that class join us for Thursday night. Okay? Because most of you are in the server class. Okay? So I'm just going to have one night out. I can't be going out drinking beer every other night. Okay?
You could.
Now, here's the deal. Here's the deal. I buy the pizza. You guys buy the beer. Okay?
That's easy.
You guys buy the beer.
How much can you drink?
Well, I'm pretty controlled. I'm pretty controlled. All right, guys. So, let's talk about Lab 8. Let me pull that up. Let's see what we've got here. First, let me open. Okay, so here is Lab 8. How many of you were able to figure out the variable length subnet mask? Okay, very good. Everybody else not quite sure? All right.
You know how variable lengths like Subnet have to have like different IP addresses, like I've
Well,
seen in the PowerPoint?
they have to have different variable length masks, okay, as the name implies. Okay? So let's pull up Notepad.
I know there's that thing that website showed that we could practice the variable length subnetting.
Yep.
thing, right?
Yes. All right, so where is my mouse? Oh, here it is. Why does it do that? Okay, to begin with, how many networks do I have?
Looks like you have 4 in total.
We have 4 networks, okay? And you'll notice that I specified for each network how many hosts. So we're going to start by listing the networks based on the number of hosts. Largest first to smallest, okay? So network A is the largest, correct? So then we've got hosts, block size, network ID, first, last, and I'll worry about the rest later. So first we've got A, which is that. How many hosts did we say? 100 hosts. All right. Then we've got B. How many does B have? 45. Did C have anything larger? 20. Okay, so I basically listed them in order, so I made it a little easy for you. And how many hosts does D have? It has 2. Okay. Now, remember, a block size is a power of 2. Okay? What is the smallest power of 2 that will hold 100 hosts? 128. Okay? And for 45? 64. And for C with 20? 32. And finally for D?
4.
4. Good. So next, the network ID is going to start with 0. Then 0 plus 128 gives me 128. Plus 128 plus 64 gives me 192. Plus 192 plus 32 is going to give me 224. And just for kicks, 4 plus 224 gives me 228, right? Okay.
I think you forgot the broadcast address, broadcast address.
Yes, I'm not quite there. Okay. CIDR. So what's my first address? One more than the network ID, correct? 1. $129. Thank you. 193. 225. And nothing there. Okay. What's the broadcast address for my first network? One less than the network ID of the next. 127, 191, 223, 227. Okay, then 126, one less than the broadcast. 190, 223, or 222, I'm sorry, 222, and 226. Okay? Now, I think the CIDR address, what did we start with? 192, 168, what? 100? The IP address that I had you start out with. .100.0. Okay, let's put that down so we keep that. And that was a /24. So we extended, okay? So if I have a block size of 128, all right? What is my CIDR going to be? Very good, 25. And I'm just going to put a /25 there, okay? How about for network B? 26, 27, and very good, 30. Okay? Everybody good? All right. I'm sorry?
I said I was going to probably try to get a picture of that.
Okay.
Oh, I'm accidentally taking a selfie.
All right. So, everybody got this? Because I'm going to take this down. Now, so network A, one of the things that's going to help you is to basically write this stuff down, but network A what is its network ID? Right. And it is a /25, okay? So what I like doing is my router interface is going to be at .1.
So that's going to be the gateway?
Yes. Okay. What do you want to make for your switch?
It's supposed to be like a next door.
Okay. So that's going to be .2. That's going to be for what port? Yes, VLAN 1. Okay. All right. Now, network B. What is the network ID on network B? 128, and that is going to be a /26, correct? Okay, again, I'm going to specify what address for the router, the lowest address for the router. 129, right? For network B? For network B?
Yes.
Okay, yep. And then we'll specify for the switch is going to be what, gang? 130. Okay, good. Next, I've got network D. I'm still looking at router 1 here. I've got serial 00 and serial 00 connected, 2 hosts. Let's look at network D. And that's going to be 192.168.100.192, correct? Slash, what was that? 27. Oh, network D. You are correct. You are correct. Thank you. Yes. No. I made a mistake. Is 224. Thank you, Sharon. You're correct. And George, 30. Okay. Good. All right. Now, so the address I'm going to give on this I always go from left to right. Okay? So 225 and then .226. Okay? Okay, so now we're on to network C. .192, 168, 100.192 with a /27. All right, and we are going to assign the router interface as .193, correct? 193, and then my VLAN 1 is going to be what? 194. Yes, thank you. Okay, are we good?
Then we need to establish what the IP addresses will be for PC1 and for PC0.
Well, didn't we say we're doing DHCP on all this?
So it's just gonna
Right. But we do have to, set this up. Oh, wait a minute.
DHCP server is server PT that's gonna take care of all that.
I'm starting to forget. I looked, yeah. Let me pull up Lab 8, the instructions on Lab 8 real quick. Yeah, okay, I've got the right network. Yeah, okay. So router 0 will provide addressing for A, B, and C. Okay? Very good. So let's first configure all of our interfaces first, okay? Because we've got everything figured out. I'm not going to specify any passwords, simply to just keep this thing real easy. Okay, and let's open up our notepad, and that's over here. Okay. I'm not going to worry about configuring our switches. I'm focusing on our routers primarily. So we've got router 0. And host name, router 0. Interface F00. IP address is 192.168.100.1 with a 255.255.255 dot what, gang?
If you gotta look at the solder, maybe 128.
Very good.
Because you gotta look at the
I have to do it in dotted decimal, okay? So description, network 8 or network A, and no shut. Everybody good with that? Interface F01, which is to network B. Is going to set to IP address 192.168.100 dot that's going to be 129 with a 255.255.255 dot what, everybody?
So
192. And again, no shutdown. Okay? Okay, interface. What's the next interface we need to configure? Talking router 0. What side are we on? Network 0 or router 0 is, what do we define this as? Is it DTE or DCE? DCE. So the clock rate goes here. Okay, everybody good? So now let's work on the interfaces for router 1. And there's a lot of similarity between all of this. So we're just going to copy this. Oh, I forgot to copy host name.
I think you're talking about it.
You what?
You're about it, like Chap,
Yeah, it's okay. It'll survive. All right, so F00. What's the IP address going to be on that? Very good. And what is what are we using for the subnet mask? It's a slash what? We said slash 27. So what is the what does it make that? Yep. 224. Thank you. And this is network C, correct? Do we need to have a interface F001? No. So we'll get rid of that. Now we're doing serial 00. And this is connected to network B. Do I need the clock rate command? No, because this is the DTE side. And I just need to change the IP address to 226. And we keep the subnet mask at 252. Okay. Are we good? So this should get me all of my my interfaces configured, correct?
Yes, set that up. Will you need to change the interface for network D to S0/1 since it's the
On router 1 or router 0?
for router 1?
Okay. You want to make it S01 rather than S00 because the other side is S00, right?
Right.
Okay. You got two switches, George. Okay. You want to interconnect those two switches. Does it really matter if you plug one end of the cable into port number 12 and the other end of the cable into the other switch at port number 12?
It just matters if they're connected.
Just matters that they're connected. Yeah.
So
The fact that you're using the same port number on two different routers, it really doesn't matter. Okay? If it makes you feel better, I mean, you could use serial 1. It wouldn't make a difference either way. Okay? But, you know, I'm getting old. My memory's not quite what it was, so I like to try to keep things as simple as possible. Okay? All right. Super. So what's next on our list? Let's see. Router 0 is going to provide all DHCP addressing. Well, one of the things, the first thing I want to do is I'm going to go over to my, as soon as I find my mouse, I want to configure all of my workstations to use DHCP. And that's set to DHCP, so we're good. Notice the address that it picked up, 169.254, right? That's one of those automatic addresses, okay, when it can't find anything. So right now that's temporary, but that tells you it doesn't know what its IP address is. So it's just picked one out. All right, let's go to PC1. Again, settings, DHCP, Fast Ethernet, DHCP, and you'll see the address. There it goes. It pops up.
But that one's not the one we're expecting, right? The one.
No, we have to configure DHCP yet, Steve. Okay, so again, settings, DHCP, Bluetooth, DHCP. It should pop up. There we go. So our workstations are now configured. How about, I'm not going to worry about the switches in VLAN 1. I really don't care. But what did we say in terms of the addressing for serial 00? You've got the server up there, server 0. What IP address did I ask you to assign that to? Configure server 0 for providing the following services. Syslog, okay. It must be excluded. It must have a statically assigned IP address. So I don't think I specified. I don't see it in my own instructions. All right, so we assigned 194 to the switch. How about if we assign 195 to the server? So that's going to be a .195. Is that you or me?
That was my phone. Sorry.
Oh, that was yours? Oh, okay. Very good. Okay. Good. All right. So let's go on to the server. And we said we're going to set this up with 100. And what is the default? What is the router address for server 1? I think it was 193. Is that correct, gang? The network ID was 192, wasn't it? Let's go back. Okay, 193. All right. And the address we set to 195. Okay? Everybody good? Super. Okay. So that's good. Ah, yes, good point. Good point. So this is network C. What was CIDR? How many bits did we have for CIDR on network C? That was /27. Therefore, our subnet mask has to be 255.255.255. What, Steve?
224.
224. Thank you. Very good. Sweet. Default gateway is 192.168.100.193. Okay? Now, all of our DHCP is going to be configured on router 0, correct? And router 0 is providing DHCP for network A, network B, and network C. But not network D. All of network D is statically assigned, correct? Okay, so there's router 0. Well, I'll tell you what, let's go back to our commands. let's do that instead. And we're configuring router 0. And let me just find something else to use here. No, I don't want to go
You
this
are
way.
the last party in the conference.
Okay, that's fine. What am I doing here? Yeah, I'm opening up Notepad. So what I want to do first, I want to exclude certain IP addresses, correct? For my router interfaces and for my VLAN 1s on my switches. So, let's start with network A. What is the router interface for network A? 192.168.100 dot what? Dot 1. Okay? And
So you're gonna put it online, right?
yes.
Alright, you got to leave right now, that's fine.
All right. Very good,
Alright,
Steve.
I'll see you Tuesday.
That sounds good.
Alright, hopefully.
Have a good
Tuesday we can
weekend.
Get the thing done sooner.
All right, now we're now into, and how do I add a comment in here? I put an exclamation point, and I say network A. Okay. Then this is going to be network B. And what's the router IP address on network B?
Uh,
129, right? Right? For network B right here. That's 129. And what's the switch address? VLAN 1? 130. Very good. And for network C, okay, for network C, what is my router interface address? 193, and my VLAN? 194, okay? Oh, yes. Good. Thank you. So that's 195. Okay? All right. Next. One second. Here we go. And what I'm doing right now, what you don't see, is I'm just copying pieces of code that I already have stored on another text file. And I'm just bringing it over here and I'm going to pop it in. And then I'm just going to fill in my pieces, okay? Network A. And the address on that is going to be 192, 168, 100, and what's its network ID? It's 0. And subnet mask 255, 255, 255 dot 128. And what is the, oh shoot. Okay. What is, why do I keep doing that?
Instead of hitting control, I think you missed the control key. So
Oh, okay, so I didn't copy it, okay.
See there.
And we said that the router interface is .1. I really don't care about the IP name server. Okay?
Fix the network on the line after that.
So now,
You fix your network, right? It says network line.
oh, yes, okay.
Yeah, that's where you.
Yeah, what the heck did I do there?
Most of the control is register.
Oh, okay.
That's why you're putting a C in there and power your.
Got it. Yeah, there we go. Okay. Copy. Paste. Paste. What's the network ID on network B? 128. And what is the subnet mask? And the router ID is 129, correct? Okay, what's the network ID on network C? What did we say? That was 192? And the subnet mask was 224. And default router is 193. Okay, is everybody good? No, we don't. You can put an exit, but I'm not going to put one in. Okay, it's fine. And I'm going to add. We know that router 0 is our DHCP server, right? And by itself, DHCP can only handle networks that are directly connected to that DHCP server, right? In order to provide service to network C, all the way over here, we have to set up a relay, a DHCP relay, and the command to do that is IP helper address, and we identify the address. So we put that in with the interface for that network. So IP and helper, I think it's dash address, on router 1. Now, what address should I give it? Well, router 0. But what interface here should I give it? You want to, because the router is the DHCP server, we want to give it the closest IP address for router 0. So the closest IP address is 192.168.100.225. Okay? Questions? Does that make sense? What do you say we take this stuff and we load it into the respective servers or routers? Copy it. Let's go in here. Okay. I'm going to have a sore neck by the end of the night. And we want to paste this in. Didn't like something. Oh, I put a space in there. Oh, my bad. Hold on, gang. Ah. My bad. Damn it. Let's try it one more time. Okay, so it likes that. Okay? Now let's do router 1. We're almost there. I know some of you have to leave, so don't feel bad if you have to get up. And let's paste this. Okay. Everything looks good. Let's go in and check it. Notice that the router is or the switch is reconfiguring itself. Okay? You see that orange light there. Let's go over and take a look at PC1, see what it's doing. Notice PC1 now has a correct IP address. Let's check PC0. It too has a correct address. Let's check oh, this is PC0. And it does not have a correct address yet. It may take a moment. Let's just give it a moment. In the meantime, let's take a look at our other configurations. That looks correct. That looks all good. Okay. All right. Let's make sure that everything. Okay, so I've got my helper address at 192.168.100.255. Oh! I'm surprised that you all didn't catch me on this. What did I forget? Yes. Very good, thank you. And that's router 1. Let's do this on all right, now, still nothing. Okay, it may take a moment because RIP has to get updated. So let's try to do this. Do ping 192.168, 100.1. Okay, I've got success. I'm pinging all the way across. Let's see if I can make it to, what's PC0 here? Or PC2, I don't know what it is. 100.3. So ping 100.3. Let's see if we get over there. Good, I've got it. So I'm pinging through. And notice, we've got a correct IP address on that. Okay?
Sorry, but how do you ping how did you ping that again?
Well, the ping command is, number one, what mode must you be in for the ping command?
Looks like you're in global.
Normal, the privileged mode. Okay? But you can do it if you put do in front of it. Okay?
That's where I'm
Yes. If you say do ping, fine. All right. Is everybody good?
It's the,
All right. I think NTP is pretty straightforward. syslog was pretty straightforward, right? Did anyone have questions on it, TFTP? Just real quick, I'm going to hit Control Z. I'm going to go back to my privilege mode.
You said that syslog is pretty finicky, right? It just didn't report back. I mean,
Yeah,
I would
yeah.
label I would see certain things go in there right away.
Right.
And after I would go into the lab later on, like I restarted later on, I went back into it and
Yeah, there's not a heck of a lot to it.
10 minutes,
That's right.
and it wouldn't do anything.
That's right.
I found if you do something to like the router or the switch or
Correct.
something, it's
Every
like
once in a while you get something.
you would get something on
Yeah.
that, but yeah, I was driving crazy for a while.
So to back up the running configuration, I'm going to say copy run TFTP, and then I'm going to specify the host address for our server, which is 192.168.100.195, correct? I think that's right. And the destination file name, I'm going to call it router 1 running config. And why isn't it running? Because I didn't turn TFTP on. So you turn it on up there. Let's go back to our router. Let's try that command again. Oh, it wrote it, because once I turned it on, it wrote it. I'll just do it again. Okay, 192.168.1.195. And I'm just going to take the default file name. Oh. Try one more time. There we go. So you can see how fast it copies. Okay. All right. Questions? Okay. So I'm going to shut down the recording, and